Hello and welcome to this video. And today we will continue our discussion in domain 3 of CISSP. We have already looked the concept of security architecture and security engineering. Architecture is the design part and engineering is the implementation part. We have also looked some of the concepts of defense in depth, for example, but to apply those concepts, the secure systems also need to have a solid design around it. And how do we manage design of those systems? Is through 5 architectural concepts which are very important, and most of the digital and IT infrastructure as we see today are built around these concepts. So the concepts are domain separation, layering, encapsulation, redundancy, and virtualization. So let's start with uh, layering first. What does layering do? Is literally segregates the functionality of either hardware or software or both into different layers. And the reason we do it is that we can influence layers standalone so that we contain the impact of a particular layer, which will also allow us to make and build modular systems. For instance, if you want to change a software configuration, you do not have to change the hard disk. Because of the layering concept, the impact and the functionality is kept separate, which means you can change one without directly impacting or influencing the other. The next concept is what you call as abstraction, uh, which is a extension of layering, because what layering does that it abstracts the functionality of a particular layer in a way that the layer above it and a layer below it do not see in totality the function, but only the layer exposes through their interfaces the data that needs to pass through each layer. An abstraction is important because it hides unnecessary details which may or may not be required for different layers to operate. So it cuts the noise, it passes the information which is absolutely necessary. It is also achieved, for example, at the operating system level through encapsulation. And one of the examples you will see that if you set the UID bit in Linux, it suppresses the access to a file only to those processes which has a matching UID and not to everyone else. So that's how the UID encapsulates the access. Now we are not talking about domain separation at this point of time. That is something we will see in a couple of chapters later. Also, virtualization and redundancy, it's a big concept, but we will see those in conjunction with the cloud security and cloud management, because virtualization is a technology which has made cloud famous and uh, such efficient as we know today. So this is in the nutshell the architectural concept that you have to keep into consideration for your secure system design. Uh, it is also important that your systems have security domains, and that is where the domain separation concepts comes into a picture, and that has to do with segregating your domains in a way that part of it can only be accessed by the system and not by the humans or not by any other processes initiated or created by human. They are defined in different modes. For example, the absolute system mode is a kernel, which is only accessed by root processes or processes which has been originated from root or BIOS or from your uh, core of operating system. But since an operating system also need to interact with user, otherwise it will not derive its value or benefits, it also has a user mode. And again, kernel exposes itself to the user through API interfaces and not directly. Otherwise, if you make, for instance, changes directly in your BIOS, then you know from the concepts of hardware security module that a tampered HSM will create problem with your operating system and make it vulnerable for both inside and outside attacks. System can also be designed based on whether you want to design it as an open system or a closed system. The distinction lies in the fact that the open system help you to connect various other systems quite liberally. However, the closed systems are tightly bounded by the configuration of ports, proxies, a stronger authentication management, which means you really require to have a proper, for instance, license to get connected to them. Both have their benefits, both have their pros and cons, and that is something we will see in more details in the later part of this chapter. Now, this is something we have already seen in the last session, but defense in depth or the layered or the onion model uh, also brings in all this architectural concept, the design into implementation in in such a way that you can put your defenses in layer, just like layering, what we have seen for software and hardware, and make sure that your security layers do not carry the same kind of weaknesses across. Now, it is also important that the concept of defense in depth is not just thought of from a technological perspective, but it should also be from a perspective of people and processes. So the people, process, and technology aspect needs to be covered. Otherwise, you can think of a scenario having a well-configured, well-maintained data center, but with no physical security. Somebody will just walk in and probably end up damaging a cable or the server rack or the electricity supply or the air conditioning module. So that's why defense in depth is as a concept which, even with the digital architectural principle, can also be applied to non-digital aspect, that is the physical world. And of course, processes helps the people part to interact with technology, and therefore process part is also applicable, and is under the implementation zone of defense in depth. So with this, I'll stop. I hope you got the gist of the architectural principles and where it can be applied. We will continue our journey in the next session. Thank you very much.